Exponential functions, half-life, and doubling time. Special types of exponential functions that look at the base of 2 and 1/2. Half-life and doubling time problems. These types of problems use the bases of 2 or 1/2. There is an initial amount or value represented by A. The tricky part of these problems is you're given two times in the problems. One is represented by T, and the other time will be represented either by H or D. The H represents having time, and the D represents the double time. The other number represents the time you want to find your solution. Let's look at doubling time problems. Y is equal to A. A is the initial value. 2 is the base. The variable D is the doubling time. And the time at which the question is asking about is represented by T. A doubling time problem, example 1. In a lab experiment, 3,500 bacteria are placed in a petri dish. The conditions are such that the number of bacteria is able to double every 19 hours. How many bacteria would there be after 21 hours to the nearest whole number? So again, we're going to use the equation y equals a base 2 of t divided by d. The initial value is what? That's right, 3,500. The doubling time is what? 19 hours. The time that we want to find our solution at is 21 hours. We're going to plug the values into the equation and we will get y is equal to 3,500 times the base 2 taken to the exponent of 21 divided by 19. Our answer will be, that's right, 7,529.8, which will round up to 7,530. Let's look at another doubling problem. A person invested 8,800 in an account growing at a rate allowing the money to double every 15 years. How much money would be in the account after 4 years to the nearest dollar? Again, the equation is y equals a base 2 to t over d. The initial value is what? That's right, 8,800. The doubling time that it takes the money to double is what? That's right, 15 years. So then the time that we're looking at is how long? 4 years. Again, we're going to plug our values into the equation, and our equation becomes y equals 8,800 base 2 to the exponent of 4 divided by 15. What is our answer going to be? Please use desmos.com to calculate it or your calculator. That's right, we're looking at $10,586.62, but they want it rounded to the nearest dollar, so it's $10,587. Now let's look at halving time problems. Notice that in this case, the equation is y equals a, where a is the initial amount, and 1/2 is the base. The variable h is the halving time. The time at which the question is asking about is represented by T. Half-life problem. This is where your halving time is used the most. Element X is a radioactive isotope such that every 11 years its mass decreases by half. Given that the initial mass of a sample of element X is 60 grams, how much of the element would remain after 25 years to the nearest whole number? Again, we're using the halving equation. The initial value, A, is how much? That's right, 60 grams. The halving time is how long? It is 11 years. The time that the problem is asking for is how long? 25 years. Plug the values into the equation and you will see that we have y is equal to 60 base 1/2 to the exponent of 25 divided by 11. Please plug this into your calculator and let me know what your answer is. That's right, the answer is 12.4 or 12 grams. Having time problem example 2. A new car is purchased for $29,000 and over time its value depreciates by 1/2 every 3.5 years. What is the value of the car 20 years after it was purchased to the nearest $100? Look at the equation y equals a 1/2 to t divided by t. The initial value a is what? That's right, the car is $29,000 to buy. What is the doubling time? Actually, what is the half time? That's right, 3.5 years. The time that we want to look at is how long. We want to see what the value of the car is in 20 years. So again, we're going to plug the values into the equation, 29,000, 1/2 to the exponent of 20 divided by 3.5. And what is going to be your answer? Please put it into your calculator. That's right. The car is going to be worth $552, or if you round up to the nearest hundred, it's going to be worth $600 after 20 years. Thank you for your participation.